In graph 6.5, we investigated what happens when a budget constraint kinks outward. In this graph, we'll now investigate what could happen if it points inward. The key feature of this graph is going to be that the budget constraint that's formed by an inward kink is non-convex, which means that you can choose 2 points that lie on the budget constraint with all the in-between points lying outside that budget constraint. And it makes it possible for the consumer to have 2 rather than just 1 optimal solution. We begin by drawing 3 indifference curves from an indifference map that satisfies the usual assumptions. That is to say, an indifference map that represents tastes which are rational, continuous, and that exhibit the properties that more is better and averages are better than extremes. Next, we draw the first part of an inwardly kinked budget constraint, the part that's steep, and we draw it so that it's tangent to the middle indifference curve at point A. We then complete the budget constraint with the shallower part that, together with the steeper part, creates the inward kink. And we can draw this shallower part also tangent to the same indifference curve, now at point B. Bundles A and B are now both optimal for this consumer. They both lie on the highest possible indifference curve that can be reached, while still touching some part of the budget constraint. The reason that we have 2 possible optimal solutions in this case is because of the kink point that lies at 8 shirts and 6 pants. This kink point creates a non-convexity of the budget set. You can pick point A and point B, both of which lie within the budget constraint. But the line segment that connects A and B lies outside the budget set. This is what makes the budget set non-convex. Strictly speaking, a kink in the budget constraint is actually not required for the possibility of 2 optimal solutions to emerge. As we'll see in graph 6.7, all that's really needed is the non-convexity, and an inward kink is one way that such a non-convexity can emerge.